contribute to hardness, but the contribution of these ions is usually negligible. Okay, so you have this carbonate hardness. This is total hardness. Carbonate hardness is due to the presence of bicarbonate. So the calcium bicarbonate, magnesium bicarbonate, and carbonate. Carbonate and bicarbonate contribute to this carbonate hardness. Carbonate hardness is chemically equivalent to alkalinity. So I think most of you are very familiar when you talk about alkalinity, especially when you are dealing with biological process. Because alkalinity is very important as one of the parameter that you need to control whenever you have this biological process, because this alkalinity will make sure that, of course, there are certain range that you cannot have in your wastewater treatment plant or biological treatment plant. But there are certain value of alkalinity that you need to maintain. If you don't have this alkalinity in your system, finally, if there's something happens or you get some input from the influence to your treatment unit, the pH will automatically be very fluctuative. It's fluctuate very fast, so you know that your system is not stable. Okay, so unit operation for any types of treatment, you need to maintain the unit to be stable. So for biological system, it's very difficult if you don't have this alkalinity. If your system is not stable, meaning that the removal of what you want to remove in your system will not work efficiently. Okay, so this is carbonate hardness, which is equivalent to alkalinity. Non-carbonate hardness, you have contributed by salt such as calcium, magnesium sulfate, and magnesium chloride. So total hardness is the summation of all the carbonate hardness and non-carbonate hardness. Okay. Okay, forms of hardness just now: hardness due to calcium, hardness due to magnesium. So they are total hardness. Carbonate hardness associated with carbonate and bicarbonate alkalinity, together with non-carbonate hardness, which is associated with other anions, you will get total hardness. So this is the thing that you need to remember all the time. Okay. Okay. Total hardness is carbonate hardness plus non-carbonate hardness. Okay. Carbonate hardness, they are sensitive to heat and precipitates readily at high temperatures, therefore can be removed by boiling the water. Okay, you know that carbonate hardness due to carbonate and bicarbonate of calcium and magnesium and a few other ions here, a few other cations here. Okay, so they can be removed by boiling the water. Okay, so that's why they are called temporary hardness, because precipitates readily at high temperatures. Non-carbonate hardness are permanent hardness because does not precipitate readily at high temperature. That's why you need different kind of treatment for permanent and temporary hardness. But of course, even though you said that carbonate hardness can easily be removed by boiling the water economically, and also if it is in a large amount of water, of course, boiling the water is not an efficient treatment unit, especially economically. So that's why hardness, even though they are temporary, where you can remove by boiling water, usually industrially it is not carried out that way. They don't boil the water just to remove the carbonate hardness. Okay, because you will use lots of energy to boil the water. You can use it if you have like maybe in some states like maybe Kelantan, they use lots of groundwater for their water source. But so if they have this groundwater from this and then they can just boil the water to remove the hardness because they just want to consume for small amount. Okay. Okay. Okay, so this is the formula. So milligram per liter as calcium carbonate. So how you get this milligram per liter as calcium carbonate? The only thing that you need to remember, the hardness unit is the same as that consistent unit used for both of the above ions. The most units used are milligram per liter as calcium carbonate. So how do you want to make sure that the unit is consistent? So milligram per liter as species, what you want, you have to multiply by equivalent weight of calcium carbonate divided by equivalent weight of species. Okay, so this is the formula that you need to remember. So where EW is equivalent weight, species, ion, or radical or compound. Radical such as carbonate, sulfate, compounds such as CO2, CaSO4, calcium sulfate. So radical is when you have cations or anions, but compounds are when you the cations and anions have been neutralized, like a carbon dioxide compound or calcium sulfate. Okay. So for equivalent weight for radicals and compounds, so molecular weight divided by electrical charge. Okay, so like this. Okay, CO2, what is the charge? Okay, maybe this is CaSO4, what is the charge? Rule of thumb, what is Ca, what is the charge? What is the Ca charge? Okay, Ca, maybe you don't remember. SO4. These are some of the rule of thumbs that you need to know when you deal with this any compounds or ions. What is SO4? What is the charge? Anybody knows? SO4, what is the charge? To make that compound neutral, what is the charge? Any students remember what is the charge as SO4? Anion, what is the charge? Semua tak tahu ke? SO4? How many of you have taken wastewater treatment? Okay, Ca, calcium, what is the charge in the table, in the ionic table? What is the Ca, the charge of Ca? Amirul?
Yes, Prof.
What is the charge of Ca?
I'm not sure.
You don't remember? Ca is 2 plus, right? SO4 is 2 minus. That is the charge.
Oh, okay.
Itu charge. Cation and anion to become, I think you have, what subject? What subject have you taken for this introduction to environmental engineering? I think you deal also with a few chemicals, okay? Jadi CaSO4, Ca2 plus, SO4 2 minus. So they are they become a compound because the cation and anion have neutralized the charge, calcium sulfate. So they become calcium sulfate. So Ca2 plus, SO4 2 minus. So the electrical charge for this compound is 2. Okay. Molecular weight, of course, whatever, let's say if you have Ca is what, 22 something. I don't remember. So you can look at the table. Oxygen is 16 times 4, as I don't remember. So Ca, I think 24. So you need to look at the ionic table and you will be able to get the molecular weight of that element or compound. So you know what is the molecular weight of calcium sulfate by putting every element that you have in that. CO2, C12 carbon, oxygen is 16 times 2. 16 times 2, 32 plus 12, so 44. So carbon dioxide. Okay, so this is the equivalent weight. When you want to calculate equivalent weight, you need to know the molecular weight and also the electrical charge. Okay, so for radical, Ca3 2 minus, so it's easy for you to see that the electrical charge for this radical is 2, SO4 2, okay? And also for ions, equivalent weight, molecular weight divided by valence. Okay, if you have ions, let's say you have H plus. So the molecular weight is 1, the valence is 1. Okay, that one is for ions. The electrical charge or the valence to determine the equivalent weight. That is the molecular weight of the species. Okay, so this is one of the example. Calculate the equivalent weight of the following ions. So let's say you have hypochlorite ion, OCl minus. So Cl, you know, the hypochlorite ion, the molar mass of this one, oxygen 16, Cl 35.5. This is the values that you can look at the ionic table. The table. So you get that for OCl, hypochlorite, the molecular weight is 51.5 gram per mole. This is 1 mole of hypochlorite. So the equivalent weight is 51.5 gram per mole divided by what is the valence charge. This is 1. Minus is 1, meaning 1, only 1. So 1 equivalent per mole. So finally you will get 51.5 gram per equivalent. So this is the equivalent weight of hypochlorite ion. Okay. Senang kan? You just look at this example and you can try with other ions. Okay. So calculate the equivalent weight of the following chemicals used in water processing. So let's say this is, you have compound ferric sulfate, which is used in coagulation. So this is ferric sulfate, Fe2SO4 3. So the molar mass is for ferrum, when you look at the table, ionic table, it is 55.9. So you have to multiply by 2 plus S 32.1 plus 4 of oxygen element, multiply by 16, and the whole of this lot, the sulfate, you multiply by 3. So you will get for ferric sulfate, the molar mass is 400.1 gram per mole. So 6 equivalent, what is the equivalent mole? You know that SO4 2 minus, you have to multiply, because sometimes ferric is, you have ferrum 2, you have ferrum 3, so it's a bit difficult for you to know the charge. So maybe SO4 2 minus is something that is very familiar. So you know 2 times 3, so the electrical charge is 6. The electrical charge for this compound is 6. So 6 equivalent per mole. So the equivalent weight is 400.1 gram per mole divided by 6 equivalent per mole. So you will get 66.7 gram per equivalent. Okay, so it's easy, right? You can just look at the table to get the equivalent weight, and then finally you will be able to get the you can convert the concentration into whether you want it to be milli equivalent per liter, or you want to the concentration of hardness as calcium carbonate. So this is one example. Convert the following concentration into milli equivalent per liter. So you have 85 milligram per liter Ca2 plus. So Ca2 plus, you know that calcium is 85 milligram per liter. Example, 85 milligram per liter Ca2 plus. So you need to first get the equivalent weight first. So the equivalent weight is 40.1 gram per mole for Ca calcium. When you look at the table, the equivalent weight is 40.1. Okay, so you need to divide by the electrical charge, which is 2 here, meaning 2 equivalent per mole. So you will get 20.1 gram per equivalent. You can also, since they want it to be in milli equivalent, so you can convert 20.1 milligram per milli equivalent. So the unit that you get from gram per mole is gram per equivalent. So you can convert into milligram per milli equivalent because the question is asking for units in milli equivalent per liter. Okay, so for 85 milligram per liter Ca2 plus, you will get 85 milligram per liter multiplied by the equivalent weight, which is milli equivalent per 20.1 milligram, because you want it to be in milli equivalent per liter. So the instead of you multiply, actually you divide 85 milligram per liter, you divide by the 21.1 milligram per milli equivalent. So when you multiply, it's become like this. So this is what you get for C8, 85 milligram per liter of Ca2 plus is equivalent to 4.2 milli equivalent per liter. Okay, actually this is only about unit conversion. Okay, maybe if you, because of course things that need to be calculated when you just listen to what I explain, maybe you don't quite understand, but if you do it yourself, then you will be able to grab whatever explanation that I'm giving now. Okay, this is another another example of converting the milligram per liter as calcium carbonate. Let's say you want to convert 37 milligram per liter of Ca2 plus into the unit of hardness as milligram per liter as calcium carbonate. Okay, this is, I don't, I know that civil engineering students, they don't really like chemistry, but these are some simple chemistry that you need to know when you are dealing with any water or wastewater treatment. So you need to at least have some some knowledge or some chemistry in your head, and then because yesterday I got WhatsApp from one of my previous student, my civil engineering students. I think he kind of I think he prefers to work in civil engineering area like maybe design, office or construction. But finally he ended up, yesterday he told me that he got this from IWK, Indah Water Consortium, to work in wastewater treatment plant. Okay, so actually this is a very good very good career as well, because nowadays we are talking about sustainability, and we have to make sure that every industry they have competent person. So if you are civil engineering, actually you got extra advantage, because not only you can deal with this chemistry part of water and wastewater treatment in the process, but also you'll be able to know how to construct, to build the facility yourself. So I think you will gain extra when you have your interview with all this like a big company about their water or wastewater treatment plant, and they're talking about sustainability, about SDG. So this is a very important area as well that you can venture into when after you have graduated. Okay, so you need to also be able to understand some. I know that you have all the basics about chemistry, but when you go into civil engineering, maybe you have left all this knowledge because you don't really like chemistry. That's why you go into this civil engineering. But you know that nowadays it is very, very important, the knowledge on sustainability. When you talk about sustainability in water and wastewater treatment, whether you like it or not, you have to know some equations or the chemistry elements that involved in this treatment process. Okay. Okay, so this is when you want to convert the concentration into milligram per liter as calcium carbonate. Okay, so this is the first, you need to find the equivalent weight. The equivalent weight first you get into gram per equivalent, but then since the question is asking for you to convert into milligram per liter as calcium carbonate. So you convert the gram per equivalent to milligram per milli equivalent, because you see that they need this milligram. Okay, so after you convert this, you will multiply 37 milligram per liter. Actually you divide, you divide, and then you will get 1.84 milli equivalent per liter. So the equivalent weight is 1.84 milligram milli equivalent per liter multiplied by 37, not 50. So this is I wrongly wrote this. 37 milligram calcium carbonate per milli equivalent per liter. So you will get 92 milligram per liter as calcium carbonate. So from the Ca2 plus, 37 milligram per liter Ca2 plus of hardness that you have found in your groundwater, you'll be able to convert into the standard unit of milligram per liter as calcium carbonate using this following calculation. So you this is not 50 milligram, so this is 37 milligram per liter. Okay, so you can try this calculation yourself so that it's easy for you to understand. Okay, for this week I'm going to give you 2 questions on for your quiz, because yesterday we didn't have class. So for this material, it's not that much, the material for this softening part, but I want you to be able to convert from one unit to another using this following procedure. Okay, so I'm going to give you quiz on this calculation and also one more calculation and for your softening part. So I want you to know when you want me to give you the quiz. It's about only half an hour to 1 hour for you to answer, and then you submit. So I will put this quiz in the UKM folio, and I will open when you are ready. So I just want to know when you want to have your quiz, because I want you to be familiar with all this conversion of hardness. Because when you look at like when you look at the bottle, your mineral water, so you know this is the unit given. So I want to convert to another unit that is you are very familiar with, and sometimes for your design you need to convert to the unit that are available for you. So I want you to be able to convert the unit for this hardness. Okay, so when do you want me to give you the quiz? You just have to study this, how to convert from one unit to another, and then I will give you the quiz. Can I give you the quiz on, today is Tuesday. When do you, when are you all quite free this week? How about tomorrow, Wednesday, Thursday? How about Friday? Friday morning, 9 to 10. Is it okay for you all? Is it okay, 9 to 10?
Prof, saya ada lab pagi tu.
Oh, lab. So when do you all want me to give you the quiz?
Kalau at night or during night, Prof, okay?
Okay, I'm okay because I just have to set in the UKM folio.
Okay.
But because I need to give you only maybe not more than 1 hour, because it's a quiz and I'm going to grade it and put it in your final mark. So that's why I need to be I need to fix the time, because I need to give you only allowable period for you to answer the quiz. So at night, you all prefer at night?
I prefer at night, Prof.
Okay, how about the rest? Which night? Which night? Even during weekend, I don't mind, as long as I haven't gone into another part of your softening material. Which night? Tonight?
Sure. Tonight.
Huh? Tonight?
Kalau saya tonight. Tapi yang lain tak pastilah.
You all nak tonight? Tonight or tomorrow night?
Tomorrow night.
Okay, tomorrow night, which is Wednesday. Wednesday, tomorrow night at 9 o'clock or 8 o'clock.
8 o'clock.
8 o'clock. Okay, so I will write in the WhatsApp group. We will have quiz for this hardness and precipitation part on Wednesday, 8 to 9. Okay? Okay, thank you.
Thank you, Prof.
Okay, okay. So this is, we have another about 10 minutes. So alkalinity, alkalinity, as I mentioned to you just now, this carbonate and bicarbonate hardness is actually alkalinity. So alkalinity is a very important parameter in water chemistry and related very closely to hardness and softening process. This is the equation to measure alkalinity in water. So we have hydrogen carbonate, you have carbonate, you have hydroxide, and minus the H plus. H plus because it's about acid. But usually this concentration of hydroxide and actually this H ion are negligible. Okay, so the concentration of alkalinity is milli equivalent per liter or milligram per liter as calcium carbonate. Okay, the relation between the alkalinity species is given by the following three equations. Okay, So this is the alkalinity, meaning that the pH is greater from 8 to 14, meaning that the equation, the pH is not in acidic range. Okay, so this is just to show you. Actually, for calculating the alkalinity and carbonate and hardness, actually we can also use equation using this pH equation. But I think that it is a bit complicated for all of you, so I don't want to use this. Okay, so I just want to show you that this is the alkalinity is within the range when you have the pH is greater than 7 up to 14. Okay, so this is various forms of alkalinity relative and CO2 relative to pH in water at 25 degrees Celsius. Okay, so this is the okay. Water softening. Okay, you have the hardness. So now for you to soften the water. So what are the advantages of softening? First, you can reduce the soap use because longer life for water heaters, less incrustation of pipes, because you have seen what happened if you have hot water, if you use hot water. So hardness in the range of 300 to 500 milligram per liter as calcium carbonate considered excessive. So if you have your water source characteristic, you look at the hardness. What is the hardness? If more than 300, then they are considered excessive, and it indicates that you need to properly treat your you need to provide water softening unit in your system. Okay, even greater than 150 milligram per liter may result in consumer objection. So meaning that you need to remove hardness when you have 150. Okay, because these one are excessive, but consumer will also want to have water that have hardness less than 150 milligram per liter. Okay, 60 to 120 milligram per liter as calcium carbonate is considered a moderate amount removal of hardness. So how is softening done? You need to precipitate the calcium and magnesium, or you can do ion exchange of calcium and magnesium with ion such as sodium. Okay, so today our part is just to look at the precipitation of calcium and magnesium. Next week, we will still be dealing with hardness in water, but we will be talking about a different treatment unit. It is about it's about ion exchange. So this is for our next week part. Okay. Okay, softening process usually we call lime soda ash softening. Okay, we'll explain to you. Chemical precipitation is among the most common method used to soften water. Chemical use are lime, which is calcium hydroxide, and soda ash or calcium or sodium carbonate. You can use calcium hydroxide. You can use soda ash or soda ash. Lime is used to remove chemicals that cause carbonate hardness. Okay, so lime, you know, carbonate hardness that can be removed by boiling, but you use lime. Soda ash is used to remove chemicals that cause non-carbonate hardness. You know that anything, the hardness without this CO3 or HCO3 are permanent hardness, and they need to be removed by using soda ash. So let's say if you can tell that the hardness that you have in water is just due to carbonate hardness, then you can only use lime, okay, without soda ash. But if you have, if you determine that your total hardness is more than the calcium hardness, carbonate hardness, then you need to use also soda ash, because you know that your water contain non-carbonate hardness as well. Okay, so as I mentioned, temporary hardness or carbonate hardness can be removed by boiling. By boiling, you provide heat and you will get calcium carbonate and magnesium carbonate that form precipitate or solid. Okay, but usually you can use this in your house, but it is not possible for industrial scale process. Use this treatment because it will incur lots of cost for your energy. So, and then you can remove this temporary hardness using addition of lime. Then you will also get calcium carbonate as precipitate, or you get magnesium carbonate as precipitate. Addition of lime. Okay. Okay, this is the water softening. Usually this is where you put your process. You have this lime or soda ash or coagulants. You can put everything in here with flash mix. So if you have hardness in water and you also want to remove some clay amount that you have learned about the coagulation, flocculation process, so you can put everything together in one tank. You can provide lime, soda ash, and coagulants here, so that you can tackle two problems in your source of water, whether due to hardness or you have clay or whatever that you want to remove, minor particles that you want to remove in your source, water source. Okay. Okay, lime soda ash softening process. So just now we talk about boiling and also addition of lime. But here, if you have temporary and permanent hardness, then you need to use lime soda ash softening process, meaning that you add lime and you also add soda ash, so that you remove the permanent and temporary hardness together. When lime and soda ash are added, hardness-causing minerals form nearly insoluble precipitates. You see why they talk about nearly. Nearly meaning not all of these calcium and magnesium will form precipitate, but most of them will form. So you will leave some behind, because as I mentioned in the earlier part, that it's not good to have very, very low hardness in water, because the water will become corrosive. So it's good to maintain certain amount of hardness in your water, like 60 to 120 milligram per liter as calcium carbonate. Then you will get not very soft water, but you maintain some amount of hardness in water. Mg2 plus is removed in the form of magnesium hydroxide. In lime soda ash softening process, it's removed from water in the form of calcium carbonate. Okay, these precipitates are then removed by conventional processes of coagulation, flocculation, sedimentation, and filtration. So even though we learn about the softening process after, this is the week 5 or week 6, I don't remember, but in your treatment process, if you have this hardness in water, this unit operation is put earlier from this coagulation, flocculation, or sedimentation and filtration. Because precipitates are very highly soluble, some hardness remains in the water, usually about 50 to 85 milligram per liter as calcium carbonate. This hardness level is desirable to prevent corrosion problems associated with water being too soft and having little or no hardness. Okay. We have quite a so I think we have another part of this softening process, the precipitation. So I think I'm going to combine this with your next week part. So your quiz will only be on this part. Because you have class, right, at 10. I remember last time. You have class at 10. So we will stop here and I will give you quiz on this conversion of hardness unit, and about the precipitation, the removal of hardness. I will combine this part together with your ion exchange process next week, because next week we will still be dealing with hardness problem in water. Okay. Okay, student, do you have